so I'm Raffaella Villa. I'm a professor of environmental bioengineering and also the associate in research for the interim associate in research for the faculty.
Can you explain your background?
So I have originally a degree in food science and technology, but then I did a PhD in biotechnology, and originally I started working in research on applied microbial processes for production of specific chemicals which can be used in industry, in food industry or in pharmaceutical industry. And then I had a career break, and when I came back I basically joined a different group, and I started working in environment. So for the last 15 years I've been working in bioremediation, so again using microbial processes to clean up, basically, so to treat wastewater so that we can have cleaner processes.
How was that change of areas?
It was, from my point of view, very interesting in the sense that I moved from a very kind of blue sky type of research for the pharmaceutical industry, let's say, to a much more applied research, because when you work with waste, you do have waste to treat, and working more with industry, with small and bigger industry, but you see how the impact of your work. So I actually quite like that.
Your research is into applied microbial processes.
Yeah.
Can you explain a little bit more of that for people who might not know what does that mean?
Okay, so if I, for example, if I ask you how we produce beer or wine or cheese, right? It all happens through microbial processes. So there are microorganisms, bugs you can call them, which have specific action, and they can transform component inside the material to produce, in the case of beer and wine, alcohol, or in the case of yogurt, for example, you could produce specific compound. So the work that I do is using the same principle. So we take a waste and we use microorganisms, bugs, to do something, to either clean up. So in the case of wastewater, we go from dirty water to cleaner water, not drinkable water, but cleaner water. In the case of waste, for example, I do work in anaerobic digestion, so we process the waste and we produce, so we stabilize the waste and we produce also biogas.
Some of your most recent research is about fatbergs.
Yes.
Can you explain in more depth what is a fatberg and also how does it form?
So the fatberg is a blockage in sewers. So all our wastewater is taken from our household to the wastewater treatment plant through a sewer network. So sometimes this network gets blocked, and most of the time, I would say about 70% of the time, is because of this formation. And they've been called fatberg because they resemble a little bit an iceberg. They're white and they're hard, and they basically constrain the flow of water into a pipe. So how they form, we don't know yet. The main explanation is that there's a combination of fat that is released into the sewers by us, by the restaurant, by household, which deposit. So if you think about, when you cook a roast dinner, right, for example, and you leave the pan, the fat in the pan will solidify, and so that's the same principle that what's happening in the sewers as well. So your fat goes into the sewers, there's a change in temperature, and it tends to solidify, to clog, to attach to the surfaces, to the rugs, and very slowly becomes a big basically deposit, and very slowly sort of stop the flow.
What can be done to remove or reduce fatbergs? But since you said that you still don't know how they form,
No.
I don't know if that's a good question. So
at the moment, the poor people from the water industry have to go into the sewers where possible. So in big sewers, they can go down and do it manually. So they excavate manually. In smaller pipes, you can jet with high pressure water, but it's very expensive. I think they reckon that it's about £80 million per year of cleaning fatberg blockages. Now, just in Thames water, so just in the London area. So how do we avoid it? Well, we try not to put fat down the drains. The best thing would be to try to avoid anything that can cause blockages. So in theory, we should only put down the drain dirty water, and avoid anything that could be detrimental, like fat. Another very big problem linked to the fatberg is the flushable, so-called flushable wipes, because they are the one that help cementing the deposit of fat. And so again, if people could avoid flushing the wipes, that would be very helpful.
well, I also read that flatbergs have the potential to be an energy source.
Yeah.
Could you explain about that, what you know?
Yeah, they could be. So if you think about, I think we've done a study, can't remember the numbers now, but done a study with Thames water. So if we could recover the material at source, so let's say people, instead of pouring the fat down the drains, they would collect the fat and take it to a waste management. We could process that material to produce biodiesel. So that material is clean enough to go into biodiesel production. Now, if once it's down the sewers, obviously is contaminated with dirty water, with everything that goes down the sewers, so rainwater, sort of rubbish, leaves, etc. So once it's in the sewers and it becomes solid, it's difficult to process, but you can still recover energy by burning it. So like for, you know very well, if you eat carbohydrate or fat, what makes you put weight is the fat. And is exactly, so fat has a very high calorific value. So if the deposit is composed mainly of fat, you have a potential for releasing some energy by burning it. So that's how you can recover energy. But if you can recover the fat at the source, then is a cleaner fat, is a cleaner material, is still liquid, and you can still use it. You could still use it for biodiesel, so transport.
You are the co-dean's lead for net zero. For people who do not know what is net zero, if you could explain what is it and why it is important, and also your experience.
Okay, net zero is about is linked to the CO2 emissions that we are trying to curb, we are trying to manage. so that we can stop the increase of temperature that we are recording. So CO2 is just a very simple way of communicating also how to manage that and to reduce that exploitation of our resources. So the net zero is about being able to produce and use only the CO2 that is like new CO2, let's call it. So without having to dip into material that has been deposited, like oil, like coal, that has been deposited many years ago. So it's about trying to equilibrate the production and the consumption of material. From what my experience with net zero, well, I do work with waste, so obviously waste play a massive role in trying to achieve net zero, because we're trying to manage better all our resources, and at the moment we are unfortunately in a very linear economy where we extract the resources, we produce something, and then we throw it away. And since I started working in the environment area, I have been to many waste processing facilities, including several landfill, and I would say that people should go and visit a landfill, because once you go and see a landfill, your perception of how we use the material and how we use the resources, the earth resources, changes. You see this huge amount of waste, and a lot of it is actually not waste, and it is really painful to see how we are not caring about our planet. So so my experience with net zero is trying to use sustainable processes for treating the material. So all the microbial processes are sustainable because usually you don't use chemicals. So it's all kind of natural type of processes. So that's it.
Your latest research, if I'm not wrong, is about female menstruation and climate change.
Yes.
Can you explain more about this? Because I think it's interesting and it's not something that we tend to relate.
I think that study is just another kind of link to my work with Suez blockages, but more holistically with waste. We've just done a study on the impact of menstrual management waste, so the pads and the tampons, etc. Again, linking back to what we just said, is a very linear process. At the moment, all the management is quite linear, so people buy the products, use the product, and then throw them away. And we were curious to understand how this material was managed. We discovered that something like 15% of the 12.5% of this material actually ends up in the environment, so creating plastic pollution, microplastic pollution. So we just were curious of see how much was the total emission of CO2 emission of this material, and if we had a more sort of circular approach to the management, how much we could save. And it was quite interesting to see how much CO2 we could save by, for example, using reusable pads, reusable pans, or etc. But this is a very very kind of difficult topic to treat, a little bit because of the taboo that is linked to, makes a lot of people uncomfortable to talk about this, but also because people don't like to disclose their habits. So and in some area, there are occasions where people cannot use reusable products. So is a much more complicated subject, but for sure is something that needs to be re-looked and re-evaluated, because is a huge amount of waste that is produced.
There's a lot of talk about the cost of these products.
Yes.
So, do you think
Yes.
that there can be like a relation between how we use these products or why they cost that much and the impact that they can have on the environment?
You're touching a very good question. Yes, there is absolutely it is a big issue, and if you're thinking about also developing countries, if you have reusable products, you also need facilities for washing these reusable products. So it's not, as I said, is a much more complicated subject.
It's not black and white.
No, and you're right. The cost is very important, because when non reusable products have a very low price, whereas reusable product might be more expensive. On a lifetime, we've looked at the cost is probably. There is an upfront investment for reusable products, but then on a long term they are probably cheaper. But there is a component of washing that you have to have the facility to wash these products, and some people might not have it, or might prioritize other things than washing reusable parts. So it is more complicated, but it's a very good question actually.
So now I'm going to make you some questions that are not mine, are from the internet. Is bioengineering the same as environmental engineering?
Yes and no. Okay, so I would say that bioengineering, it can be a part of environmental engineering. So environmental engineering is much broader. Is a much broader definition. It involves other type of processes, chemical, physical processes, for example. Bioengineering is a massive discipline. It could be also could involve also genetic manipulation of microorganisms for environmental processes, but also study of engineering applied to the biological area. So for example, the valve for replacing your heart, in that can be also classified as bioengineering. So yes, they are not synonymous. So the bioengineering is a little bit a part inside environmental engineering.
Okay, so in the same line, there's people who also get confused between microbiology and microbial bioengineering.
So microbiology is the whole study. Okay, so you can talk about when we go to a conference on microbiologies, you got people that work in health, people that work in food, people that work in medicine, people that work in, so is really wide. So if you're talking about what you say, environmental, no.
No, this was the difference between microbiology and bioengineering.
Microbial engineering is again a part of microbiology, is an application of microbiology, so is using microorganisms to do something. So using microorganisms in processes, but microbiologists can study microorganisms in the environment, can study microorganisms in processes, and using the microorganisms in processes. So if I'm saying making cheese, or making beer is industrial. That's industrial microbiology, but is microbial engineering. Treating wastewater is with microorganisms is a microbial engineering. You can treat wastewater also with chemical processes and physical processes. So it's an application of microbiology.
Compared to other biological science, how hard is to study and work in microbial bioengineering?
To be honest, I don't think I have a suggestion, in the sense that I like, I like applied science. Okay, so for me, environmental microbiology or even food microbiology, because that's where I started, are applied processes. So I do like that application. And so for me, what I found interesting is seeing the process used. Okay, so having a contact with the industry, helping them to solve problem, helping them to improve the process. Is it more difficult? No, it's just a different side of the problem. Other people like to study more the conceptual of a problem. So the kind of the blue sky science. It depends what. I think anything. If that would be difficult for me because I don't like it, or I'm not so keen on. So I think anything can be more or less difficult, depending on your preferences. Maybe I could say if you're a female, it's a little bit more difficult to work in some areas than others.
Can I ask why?
Because of the sector, if it's a male-dominated sector, women are, sort of sometimes not valued in the work. Is becoming, is getting better, but so for example in the waste area, traditionally is male dominated, but there's a lot of female coming in and working in the area, in the subject, so it's getting better, it's getting easier, but that's the only thing. If I can, I don't think there is. I found physics very difficult, and some other people might find it very, very easy. So
Is it a field on demand?
Yes, I think so. It's a difficult thing to say because obviously I've worked with applied microbiology for the last 25 years. The processes go up and down depending on the kind of how the sector, the government moves. At the moment, with the kind of implementation of a circular economy, there is a kind of attention to what are natural processes. So microbial processes are becoming a little bit more accepted. It's not that traditionally they are not. Microbial processes are a little bit more difficult to manage than chemical processes or physical processes. So industry tends to prefer those processes where there's reliability, because obviously they, for wastewater it's very important that the water is cleaned at the end of the process. So there is obviously some area had a preferential, let's say, uptake for other type of processes. But as we are moving towards a circular economy, we are seeing a little bit more interest in natural processes. So I hope that yes, the sector will increase.
You said, for example, you work with food as well.
Yeah.
So, is there any example that you think people are not aware of it? Like, let's say in food production, the role of microbiology, for example.
Well, there are obviously the obvious one, the big one where we need microorganisms is yogurt, wine, beer. Some cheese needs microorganisms. There's, the very smelly cheese are old, kind of all processed through microorganisms. A lot of the flavors that we use are produced.
I wanted to ask about that.
Yes, so they are. So if you start, for example, my first project was on a specific smell, a specific flavor, and we were using some from distillation byproduct, so not waste, byproduct, and by using a microbial process you could produce this flavor, and the flavor could be classified as natural flavor. So that way the company was interested in that process. So it was a specific flavor that was added to some food.